Today is the 22nd of October 2025, but in 1985 Ken Perlin released a paper in which he described the Perlin Noise algorithm for the first time. This is an algorithm which he developed in 1983, which has the purpose of creating naturalistic randomness. This is important because no other algorithm at this time could do naturalistic randomness. Randomness was very machine-like, it was very artificial, so it's very hard to create realistic looking trees, landscapes, movements, etc. The Perlin Noise algorithm works on the principle that you split up each region of space into unit cubes for 3D, squares for 2D, I suppose hypercubes for any dimensions. So when you split the space into these hypercubes, you then give each edge of the hypercube a random vector that then generates a gradient in that space. So by looking at the influence of these gradients for any point in space for the surrounding hypercube vertices, you can then find the random value for that point. This then, because these points use gradients and these gradients are spread out over space, this means that the noise doesn't change drastically between each step. So if you step just within one hypercube, you'll find a small change as you move up the gradient or down the gradient or across the gradient, but you won't find a massive change like you would if you were sampling completely random noise. Perlin noise has been very useful. It's been applied to generating naturalistic textures. So for example, textures for flesh, textures for tree bark is being used to simulate the movement of trees in a naturalistic manner, and it has been used significantly in the generation of realistic landscapes. There have been two improvements by Ken Perlin himself to Perlin noise. In 2001 there was the improved Perlin noise paper. This is a 2-page short paper about how to optimize the existing Perlin noise program by using a few fixed vectors instead of completely generating new random ones each time, and using pre-generated random values rather than constructing random values all the time. So this saves on performance. Then in 2002, I think it was, Ken Perlin released this paper called simplex noise, where instead of using hypercubes, which have 2 to the power of n vertices for where n is the number of dimensions, he instead implemented it using simplexes, where simplexes are triangles or tetrahedrons or lines, and they have one more vertex than the number of dimensions. So this reduces the complexity from 2 to the power of n down to n.